Okay, got it back to normal. So let u equal the inside function, and then du would be 3x squared dx. Okay, so let's rewrite this guy. So 1 over the cube root of x cubed plus 4, and then times x squared dx. Okay, so I'm looking to see how I can replace x squared dx with something. You see it right here. So it's 1/3 du is x squared dx. So 1/3 du. This is your u, and there it is. So 1 over the cube root of u. So let's take the time to pull the 1/3 on the outside. And this can be rewritten as u to the negative 1/3. So then I take the antiderivative, which means add 1 to the exponent. So I'd get u to the 2/3 times 3/2. So I get 1/2 to the 2/3. So then I put the x's back in, x cubed plus 4. There it is. Okay, so if I'm going to do problems with e, so e, inside the e is a good choice for the u. So here we go. So I'm going to let u equal x cubed. Then du is 3x squared dx. And so again, if I rewrite this, I can see this as e to the x cubed times x squared dx. So I can put, all I'm carrying along again, right, is the integral sign. So then I can take this and replace it with e to the u. And I'm looking at this x squared dx. That can be replaced with a 1/3 du. So 1/3 du goes in. So I can pull the 1/3 out and then remind myself, oh, I know the antiderivative of e to the u. It's e to the u. And then put the x's back in. Plus c. Okay, here's another one. So in the e has just an x in the exponent, right? So you're never going to let u equal x. It's never going to be useful. So I'm thinking the e to the x in the exponent of the 5 is the use. Du is e to the x dx. Oh, let's take the time to rewrite this. So I have 5 to the e to the x times e to the x dx. Thinking, okay. So I remember always you're just carrying along the integral sign. Carry the integral. E to the x dx, I can take that out and put in du. Then I can replace this with 5 to the u. Oh, you know the antiderivative of this. That's 5 to the u over ln of 5. And then put the x's back in over ln of 5 plus c. Okay, so let's look at, that was a little bit tricky, right? Let's look at example 11. So 11, I'm looking at this. I'm thinking the inside of the radical is going to be a good u. So if I take the derivative, so derivative of e is e to the stuff times the derivative of stuff, right? So then again, I'm just going to take the time to rewrite this. 4 plus e to the 2x times e to the 2x dx. Then I'm looking at what I can plug in. So I can put the u in here. So I get root u. And then I'm looking at this. Oh, wait a second. I see this and this here, but not the 2. So you know the drill. 1/2 du. So pull the 1/2 outside, rewrite this, as u to the positive 1/2 du, carry the 1/2, u to the 3/2 times 2/3. Then I can cancel the 2's, put the x's back in, so I have 4 plus e to the 2x. All right, let's look at this number 12. They're getting a little harder. So number 12, I'm going to let u equal the inside function still. So the inside function is root x, right? Okay. So here, inside the e is the root x. Oh, how do I take the derivative of that? So derivative, decrease the exponent, right? And I'm even going to rewrite this. Remember, I've always talked about negative exponents. It's nice to put them in the denominator. Okay, so let's take this, and I was going to rewrite this, e to the root x times 1 over root x dx. Okay, so I'm thinking about what I can do. Again, only the integral sign carries along. So I'm looking at this and this. Oh, there it is. So there it is. And so I'm going to multiply by 2 this time. So if I multiply by 2, this and these 2's cancel. This gets replaced with 2 du. And then I'm going to replace this with e to the u. So 2 integral of e to the u du is just e to the u, and then put the u back in, and that's e to the root x plus a c. Okay, last one here. Number 13. So I'm going to let u equal the inside of the e function. So I'm going to let u equal 1 over x. Be careful, you're taking the derivative. Remember, it's the antiderivative of 1 over x. That's ln of x. This is a really common mistake. The derivative, you have to rewrite it as x to the negative 1. Du is negative x to the negative 2. So again, I'm going to rewrite that as the fraction that it is. Okay, so taking this, rewriting it, just separating things there, 1 over x squared dx. Okay, so I'm thinking about it. I know I'm going to carry along the integral sign. Negative 1 over x squared. Oh, look at that. It's so close. Negative du will equal 1 over x squared dx. So I'm just going to put in a negative du, and I have to put parentheses because it has to be multiplied in here. And then I'm going to say, oh, that's just e to the u. So again, if I simplify, that's negative e to the u du, and that's negative e to the u plus c. So negative e to the 1 over x plus c.